So we're going to be talking about AZ-900 and just doing a quick preparation for the AZ-900 exam today. If you have not taken the course on AZ-900, that might be okay, depends on your level of experience with Azure and other cloud services. But we'll cover the major topics that you need to understand to be able to pass the AZ-900 exam. So let's go ahead and get started. We'll be covering an overview of the exam. While we're doing that, I'll also talk a little bit about the remote proctored option as well, mainly because I know that right now most people are going to take it remote proctored. I don't think Pearson is doing in-person testing right now, so remote proctored might be one of your only options, and it's really the only responsible option at the current time. So I'll cover that in as much detail as I can as well. We'll talk about understanding cloud concepts, understanding the core Azure services you'll need to know about for the AZ-900 exam. We'll talk about security, privacy, and compliance in Azure. And then we'll talk about pricing and support in Azure. Okay, so the AZ-900 exam is designed to test foundational knowledge of cloud services. It's more of a general exam, and it's not a very technical exam. So if you are something like a system administrator and you're wanting to deep dive into Azure Active Directory or virtual machines, this is not going to go to that level. What this does is get you started in Azure. If you need to know enough about Azure to sit in a meeting and understand what people are talking about, this exam will get you where you need to be. If you're in project management or something like that, this is probably all you would need to know to be productive with Azure. Beyond that, this is focused on just fundamental certifications, and for most IT professionals and developers, it's expected that you would go on and take a more advanced exam after completing AZ-900. At a high level, this exam will measure 4 skills. So first, you're going to need to understand core cloud concepts. This will be the pros and cons of cloud computing, the difference between infrastructure as a service, platform as a service, and software as a service, and the differences between public, private, and hybrid cloud models. You'll need to understand some of the core Azure services, some of the core architectural components, core products available, some of the solutions that are available in Azure, and some of the management tools and what those are and what they would be used for. You don't need to know the details of how each of these services work. It's more about being able to understand what they are used for and describe what they do. You don't need to know how to write SQL queries or configure virtual machines with PowerShell or anything like that. Not to that level, just understanding what these things are. Understanding security, privacy, compliance, and trust. This is about securing network connectivity, identity services in Azure, the security tools and features of Azure, and also some of the other compliance, privacy, monitoring, and reporting options that are available to you in Azure. Finally, you'll need to understand pricing and support, which is obviously critical for most businesses, is understanding how much something is going to cost. You'll need to understand what an Azure subscription is and what those mean to you. You'll need to understand planning and management of costs and the support options in Azure, as well as SLAs or service level agreements and service life cycles in Azure. And we'll talk about all of these. For the exam, this is a relatively short exam. Most people finish the exam in well under an hour. And it's probably more common that IT professionals will complete this exam in under 30 or 45 minutes. If you are taking this exam remote proctored, which is probably going to be most of you, there are some things you should know about remote proctored exams that are a little bit special. If you take an exam in an exam testing center, like one of the Pearson VUE exam centers, you can just sort of show up with 2 forms of ID. You put your things in a locker and you just sit down and take the exam, and you're monitored, and everything is pretty straightforward and easy, and it's kind of idiot proof. There's nothing you can do to kind of mess that up except show up with no ID or something like that. Remote proctored is a little bit different. When you have a remote proctored exam, you're going to need a webcam. Ideally, you're going to want to be able to move that webcam around the room. It might be a little bit difficult to, if it's something that's permanently attached to a large monitor, that's going to be difficult to move it around the room. The proctor for that exam is going to need to be able to see your entire room, and they're going to want to inspect it via that webcam. So keep that in mind. Your room does need to be clean. You can't have, piles of laundry or things all over your desk. It's got to be neat and relatively clean. You cannot have any other monitors except the monitor you're using for the exam in the room. That includes any screen. And if you do have other screens in the room that can't be moved, they're going to require you to turn those screens around so that you can't see them. This gets pretty extreme. I know a lot of people have multi-monitor setups in their office, and one of my colleagues actually had was actually asked to turn a television that was mounted to a wall in his office around, which was obviously impossible because he would have had to unbolt a 50-inch TV from the wall, and that probably wasn't going to happen. So be aware of that requirement. The room needs to be quiet for the entire duration of the exam. I know this is a big issue for us right now since everybody is working from home for the most part. So be aware that you can't have people yelling and screaming around the house. So it might be a good idea to send your kids to the park or something like that. Nobody can walk into the room while you're taking the exam. That is grounds for automatic failure of the exam. It's up to the proctor whether or not that happens. I've even heard extreme cases that you can't have pets and things walking through the room while you're taking the exam. There is a pre-downloadable system checker that you'll need to run to validate that your laptop or your computer can run the testing software. You should definitely do this. If you don't, that's considered something that's within your control and your fault, and you'll have to schedule a new test for the exam. Also note that proxies, firewalls, stateful packet inspection, all those types of things can and will impact the exam testing software. So be aware that your work laptop may not be sufficient because you may not be able to turn off the proxies and stateful packet inspection and firewalls on those machines at will. Microsoft does have a YouTube video on this that you could easily search for. If you need any guidance on how to find that and you can't find it just by a simple search, please shoot me an email and I'd be happy to point you in the right direction. My email address is paul@opsagility.com, and please feel free to go ahead and send me an email if you need a link to that video. All right, so let's start talking about the more core services and cloud concepts that we're going to be discussing in this exam. So we've kind of gone over all the different sections. You have a good understanding of what those are. So let's start breaking down some of the core concepts in of the actual exam content. One of the first topic areas you're going to come across is being able to describe the benefits of using cloud services in general. This is the same whether it's for Azure or AWS or GCP, which is Google's cloud. You'll need to understand the pros and cons of cloud services. There's a lot of terminology around this space that you'll need to understand and make sure that you really have a good grasp of this. Understanding terms such as high availability, scalability, elasticity, agility, fault tolerance, and disaster recovery will all be needed for this exam. High availability is basically the characteristics of a solution or system in the cloud that allows the system to have minimal downtime in the event of patching or service outages. That's just a way of architecting those applications. Scalability, This is the ability to continually increase the size and capacity of a system as the workload increases on that system. So you'll need to understand that. Elasticity in the cloud, this is the ability to scale solutions out from from a single machine to multiple machines to handle greater workloads. And then when that workload subsides, you can scale that cloud solution back down into a smaller number of nodes or compute power. And that's elasticity. Agility in the cloud is basically the ability to deploy solutions very quickly. And the example I like to give to people is if you think of an on-premises solution that you might deploy that has, a basic 3-tier application, you'll have a web farm on the front end, you'll have some middleware servers that do some kind of background work, and then you might have some kind of database on the back end. If you deployed that system on premises, you'd probably have to have several meetings to do this, to get a bunch of different teams involved. They would all get in a room, they would talk it out, decide how big this system should be. They would deploy those systems, they would wire those up to the network. Eventually, you would get to a point where everything was configured and operational. You'd test it, run it, and you'd have a working system. If you move to the cloud, you can deploy everything through templates or infrastructure as code, and that can happen. That same system could be deployed in a matter of minutes. So that's what we mean by agility, the ability to deploy things very quickly and rapidly and make decisions on how solutions should be built and deployed in a matter of minutes. Fault tolerance, this is very similar to high availability. The difference between fault tolerance and high availability is that generally when you're talking about fault tolerance, it means that you can guarantee that the system will have zero downtime. So you build a system so that even if some component fails, another component will always be there to take over that part of the workload. Disaster recovery, this is the ability to recover a system in the event of a major disaster. This might be a natural disaster like a hurricane, or it could be something more acute like a fire in a data center, for example. This is not the same thing as high availability. This is usually described as the ability to recover to a point in time as well. So think of things like logical corruption, where somebody accidentally deletes a large chunk of data. You need to be able to go recover that data. So you might recover a database back, an hour beforehand, so that you can recover to a point in time and recover that data. Those are all things that you might do with disaster recovery. You'll need to understand the principles of the economies of scale and what that brings to the table. The concept here is that if you move an application to the cloud, it's generally cheaper to run the application in the cloud, even if it's running with exactly the same code. And the reason for that is because cloud providers like Microsoft and Amazon can build data centers much more efficiently than most companies can. Their job is to run those data centers. So they end up with a lot more compute capacity on deck, a lot more storage available, and that allows them to take advantage of those economies of scale. And so then likewise, they pass that on to the consumers, and the consumers can then run cheaper. You'll need to understand the differences between Capex and Opex, which is capital expenditure versus operational expenditure. We're going to go into some detail on that in a few minutes. And you'll need to understand the consumption-based model, which we will also cover in the next couple slides. So economies of scale. As you deploy things to the cloud, you switch from a Capex model to an Opex model. So you move from capital expenditures, the buying of things and deployment of things, to operational expenditures, or sort of a pay-as-you-go model. This also brings into the picture things like modernization. And there are two forms of modernization that we like to consider when we're talking about migrating to the cloud. One is data center modernization. Now, in the past, companies have run their own data centers frequently. They have a lot of existing investments in their own data centers. And as those data centers age and the hardware ages, they need to be replaced and upgraded. That's usually a good opportunity to modernize that investment. And that's where we talk about data center modernization, taking advantage of the newer compute platforms that are available to you in the cloud. The next is application modernization. And this is building things with new technology that gets away from the old limitations. So think of things like containerized software, pay-as-you-go services or pay-per-use services that you find in the cloud, microservices. All those are examples of application modernization. The other thing that you gain by moving to the cloud is security. And not too long ago, security was regarded as one of the primary barriers for companies moving to the cloud. And that changed about 2 years ago. And the new barrier to moving to the cloud is actually skill set of IT staff. People don't know how to run things in the cloud or how to build things in the cloud. Security is generally considered better in the cloud, and the reason for that is because the data centers are all built with security in mind. They are very tightly controlled. They follow a lot of different compliance policies and those types of things, so that the security tends to be greater. Most cloud computing systems are more secure than most organizations' on-prem data center operations. Capital expenditure versus operational expenditure. So capital expenditure are the funds used by a company to acquire, upgrade, and maintain physical assets such as property, industrial buildings, or equipment. This is very common to see in on-premises data centers. To deploy a solution in an on-premises data center, you have to buy hardware to support that software. So you would buy servers, you would buy storage area networks, you would buy networking hardware, you'd buy cabling, all of these things to deploy that solution. Beyond that, you also have to purchase a data center, which usually requires specialized building codes. It requires specialized power demands, specialized air conditioning, fire suppression systems. There's lots of things that have to go into building a data center that fall under capital expenditure. And these are all upfront costs. And we'll talk about a bit more about what the impact of this is in the next slide. Operational expenditures are expenses that a business incurs through normal business operations. So this would be things like rent, equipment, inventory losses, etc. When you move to the cloud, you move to an operational expenditure model. And this means that you pay for the compute that you're using. So there is a concept that if you work with a lot of companies that are still in the old capital expenditure mode, a lot of times you run into these situations where those capital expenditures are sort of written into the company policy. The accounting rules that they follow don't follow follow operating expenditure rules. So be aware that there might be some friction moving to an operational expenditure and having that recurring cost over time, but the end result is going to be lower overall cost and lower barrier to entry for new technology. So the consumption-based models, you have two different consumption models here from an IT perspective. You have the pay-as-you-go model, and you have upfront commitments. So in the upfront commitment, you will have an initial cost, which you can see on this graph here. That is the bottom left corner, and that is considered the barrier to innovation. This is the minimum cost you have, or minimum upfront commitment, to get a solution to work at all. And this is generally how we've done things for a long time until the cloud. The downside of doing this is that you have to estimate sort of what your load is going to be in the future for a given solution. Sometimes this is actually pretty easy because you have an existing system that does this, and you can just look at the load on that system and do a little bit of simple analysis, and you can figure that out. However, you do have to buy that amount of capacity. And then as the load fluctuates over time, it gets more, applications get more popular or fall out of favor, then you end up with a overcommitment of capacity. And that's considered a waste of capacity. So you're having to buy more computing power than you actually need. The next thing that can happen is, let's say your application gets wildly popular, then you can exceed that capacity that you've already purchased, or if you misestimate capacity, you can undersupply your capacity, and that can cause problems as well. So you get sort of this stair-step looking capacity over time to handle a relatively flat load or linear load here. So if you look at a cloud model or a pay-as-you-go model, the idea is that you minimize the initial investment, you minimize the oversupply, and you minimize the undersupply of capacity. And the idea is that you try to track your actual load much more closely so that you reduce the pay-as-you-go cost and keep that in check. Keep in mind that it is possible that somebody might deploy something into the cloud and not follow this model and have something similar to this model in the cloud. Now, this would be a bad case because that means that you're not following best practices for cloud computing because you're pre-allocating far more capacity than you need. So the idea in the cloud is to closely match and deploy services at appropriate level so that it matches your actual load over time. All right, so let's talk about a couple of quick knowledge checks here. So I believe you guys don't have the ability to ask questions during the webinar, so I will just go ahead and read it and give you a second to think about it, and then I will cover the answer. So the capability of a system to be enlarged to accommodate a growing amount of work is best described by the term A, reliability, B, elasticity, C, scalability, or D, agility. And the answer is scalability, C. Reliability is, we have not talked about at all in this webinar yet, but reliability is how well a system will maintain its uptime and performance. Elasticity is the ability to scale out and in as workloads grow and shrink. And agility is the ability to deploy solutions and modify solutions very quickly. And then scalability is exactly this definition, the ability to grow the system to accommodate growing and increasing workloads over time. So in general terms, when an organization moves to the cloud, will it see a reduction in Capex, Opex, or both? And the correct answer to this is both. Typically, an immediate reduction in Capex or a complete elimination of capital expenditures will be realized moving to the cloud. And over time, and as companies adopt newer cloud technologies, they will also see a reduction in operational expenditures. This is because you reduce the man hours required to spend maintaining existing systems. Since you no longer are responsible for maintaining host servers or networking or physical storage, that's all maintained by the cloud provider. Usually over time, you'll see a reduction in operational expenditures given the same amount of compute. All right, so next thing we want to talk about is the differences between types of services in Azure. So what you see right now is just a blank as a service. And this is very common terminology around cloud services and software services today. There are three major types of as-a-service offerings, and these apply to all cloud providers. They are the same in all cloud providers. There are other types of services that use the as-a-service term, things like database as a service and integration as a service, but we're going to talk about the three major players right now. The first one is infrastructure as a service. And what this is basically going to be doing things like you do on-prem, but doing it in the cloud. So this would be things like virtual machines, storage, networking, etc. Those are the main types of workloads that you see in infrastructure as a service. Infrastructure as a service also has the advantage of being the most flexible in terms of what you can accomplish. So that means that if there's no existing service in the cloud to do exactly what I want to do, I can always just do things like I used to, install software on a virtual machine and run the software from the virtual machine. The next is platform as a service. And platform as a service is a little bit higher level of functionality. It is a consumable service for developers who are building applications, and it abstracts away some of the infrastructure components. So you no longer see things like virtual machines and those types of things. You just get access to an individual service. So for example, in Azure, you have Azure SQL Database. That is a platform as a service offering that gives you access to a database. There are also Azure Web Apps, which are website services that you can deploy your web applications to. When you deploy a web app, you don't see the underlying virtual machines that run that service. Microsoft is running those services for you. It differs from infrastructure as a service in that you are not responsible for the operating system deployment, the patching of the operating system, the maintenance of that underlying operating system or application software. You're only responsible for configuring the service itself, and that's basically it. Whereas infrastructure as a service, you're responsible for the operating system and doing all that patching. Then the final option is software as a service. And this is where the application is delivered directly to you, and you don't see the underlying services that run the application at all. Typically, an organization would pay for the use of the application, or the application might be monetized via ad revenue or something to that effect. A good example of software as a service is the Office 365 offering from Microsoft. That's a very classic software as a service offering. There are a lot of other software as a service offerings out there. Services like Dropbox is sort of a storage software as a service. You have DocuSign, which is software as a service, and there are tons of other software as a service offerings available to you. When you compare these different service offering models across the entire spectrum here, and look at the responsibility matrix of what components you're responsible for. You look at a traditional on-premises environment, you're basically responsible for everything. Physical networking, physical storage, physical servers, virtualization software, operating systems, middleware, runtimes, data, applications. When you move to the cloud and you start using infrastructure as a service, which by the way is how most companies start working in the cloud, and most people that start learning the cloud start with infrastructure as a service, you're basically giving up responsibility of the physical components and the virtualization layer. That's all managed by the vendor. And then you maintain control of the operating system and everything above that. So you're responsible for the operating system, the patching of the operating system, making sure the backups are running on the operating system. All of that falls under infrastructure as a service. When you move to platform as a service, basically the vendor takes over the operating system and the application software itself, so the runtime and the middleware itself will be managed by the vendor. You'll be responsible for doing things like loading data, managing the application, writing the code that makes the application work. All of that will be your responsibility and platform as a service. But you can see you actually have a lot less on your plate as far as responsibility goes. When you move to software as a service, basically the vendor manages everything. The only things you're going to really do for software as a service are set up and configure the software to work with your environment. So you might add user accounts and those types of things, but the software itself is managed by the vendor. So which cloud service type requires the customer to manage the underlying hypervisor platform for their cloud deployments? So you have several choices. You have infrastructure as a service, platform as a service, or software as a service, or none of the above. And the correct answer is none of the above. That's because the hypervisor is the virtualization layer of the software, and that is in the cloud platforms like Azure and AWS, that is always managed by the vendor. Which cloud service types would best match the following situation? Several web applications have been developed internally in your organization. The web applications allow users to enter details in a form, and those details are then emailed to a shared mailbox. The form is accessible from the internet and can be accessed anonymously. And this would be platform as a service because the web applications are publicly accessible and do not require authentication. A platform as a service that allows customers to host websites without having to manage servers would be best. Websites can be deployed quickly, and you can make them publicly accessible with publicly accessible endpoints with very minimal configuration. All right, so next we want to talk about different cloud models that you'll need to understand. The first is a public cloud. Public clouds are things like cloud environments like Azure, AWS, and GCP. These are usually designed for any customer to have access to that cloud environment. They can deploy those services. They run in multi-tenant environments in almost every case, except for very specialized cases and very specialized services. And generally speaking, all the customers of that cloud provider will have access to those clouds. The next type of cloud is a private cloud, and this is typically a cloud solution that is built and managed on premises by an organization. There are other ways to implement private clouds where you would not build your own private cloud. This would be something like Azure Stack, where you can buy Azure Stack from Microsoft, and it allows you to run sort of a miniature version of Azure inside of your own data center. And that might be considered a private cloud as well. Hybrid clouds allow you to control and maintain a private infrastructure for very sensitive assets. It also gives you the flexibility to take advantage of resources in a public cloud when you need them. These are actually very common scenarios where you might have some assets that are going to maintain their presence in your private data centers, and some components of your applications that may run in the cloud. So for example, if you have a database that lives in an on-premises data center and you're not planning to migrate that, but you want your website to be hosted from a public cloud, you would stand up the website in a public cloud and then have the back end of that website calling into your on-premises data center and database so that you can get that data from your on-premises solution. Over time, the expectation is usually that most organizations will move everything to public clouds. All right. So which cloud deployment model would be best for the following scenario? A server is needed to process data for a short-term project. The organization does not have hardware that meets the performance requirement or any available staff to deploy it. The project starts in a few days and the server is not needed when the project is completed. So this is about, there are a couple of things that you might consider here. One is which deployment model would you use? And one is what cloud architecture or cloud environment would you use? So the best answer is you would use a public cloud. The primary reason you would use a public cloud, for one, the server is only needed for a short period of time. After the project is over, you're going to remove the server. So you don't want to make a capital investment in a server to run in a data center on premises. Creating the server in a public cloud would be very cost effective because it's pay-per-use billing. You could right size the server to whatever size you needed. It will probably be significantly cheaper, assuming any kind of reasonable project time, say a year or less, than buying a server and running it on premises. As far as what cloud architecture you would use, a platform as a service would be a great candidate for this because it would eliminate the need for managing servers underneath the covers. So you wouldn't need to worry about patching operating systems and those types of things, but you would still have full control over the code for your application that you're building. So public cloud using platform as a service offerings would be the ideal solution for this. All right, so let's talk about core Azure services. So there are some architectural components that we need to discuss before we get into a lot of the individual cloud services. The first is the concept of regions in Azure. So Azure is made up of regions that are scattered all over the world. We're somewhere north of 54 regions at this point. You can see on this map, there's quite a few of those. Where you see multiple circles and multiple rings in the same spot, that means that there are several data centers that would be so close to each other on this scale of a map that they would overlap. So they just put them in there as multiple circles on top of each other. So that gives you an idea of where all these regions are. There are regions in almost every major geopolitical region of the world. There are a couple of exceptions. There's nothing up in Russia for now. North Africa is missing, doesn't have anything in it yet. But for most other regions of the world, they do have data centers. And there are more data centers coming all the time. So you can see some of the ones that are that they have here with dotted circles. Those are data centers that are planned but not and announced, but not yet online. All these data centers have what are paired with another data center. And these are called region pairs. And this is a very important concept to understand. Region pairs are designed so that any default replication that happens on a service in Azure will automatically go to the region pair. And the region pairs, for the most part, are in the same geopolitical boundary as its pair. Now, there are sometimes some exceptions to these come up, but usually these happen when a country changes through policy or law what the geopolitical boundary is or what it means to them. And in those cases, Azure usually responds by standing up new data centers to support those geopolitical regions. This happened in the UK. The UK usually used the Northern Europe data center, and then the UK announced some data sovereignty laws, which basically meant that you could no longer store the UK citizens' data in North Europe. So that meant that the North Europe and West Europe, which are paired regions, were no longer covering the UK. And so Microsoft responded by standing up data centers in the UK. So Microsoft is usually fairly quick to respond to these. There is another exception that is a well-known common exception, and that is the Brazil South data center in South America. It is the only data center in South America, and its region pair is South Central US. So data that you put in Brazil South will get replicated to South Central US, but the opposite is not true. If you put data in South Central US, its region pair is North Central US. It will not replicate data down to Brazil South unless you have a service that allows you to manually choose where to replicate data, and you choose to do that. All of these regions are on the same backbone. However, the Azure backbone is not the same as the open internet. You're not communicating across VPN on the internet. These are going through dedicated network backbones for Azure. The only exception to these are the Chinese data centers in China. Those are run by 21 ViaNet, and they do not sit on the Azure backbone, so those are completely separate. And the Azure government data centers and DoD data centers. Those are also not on the same backbone, and those are completely separate. Geographies, I've already discussed geographies quite a bit, but generally speaking, all of these data centers are in given geographies, and they don't replicate data outside of those geographies. These geographies are very important, and the region pairing as a combination is very important. And if you're architecting solutions, you generally want to be very aware of these for not only for compliance reasons, but for availability reasons and disaster recovery purposes. So if you are building a solution and it needs to have a disaster recovery site, you usually want to at least consider the use of the region pair for the primary region as your disaster recovery location. The reason for that is that if let's say all the data centers in North America went down, and it was due to some bug in Azure that Microsoft hadn't caught in testing, and it took every data center down. Now, this has never happened, so this is not a real world case. But if it did, and Microsoft figured out what was wrong, and they decided they have a fix, they're not going to turn around and bring every data center in North America online at the same time. They're going to methodically choose one from each region pair and bring those online first. And once those are online and they feel that they have the problem fixed, they'll start bringing the region pair for each of those online. So if you choose two regions that are not paired as DR partners, you run the risk of those regions being in the second wave of data centers being brought online. And this is just an example of why you would want to pick region pairs. The other reason is that certain services like Azure Storage, which is the most common service used in Azure, have built-in replication. Also, all the Azure backup services that run for all the platform as a service offerings and everything all replicate data to the region pair for recoverability. So it's always a best practice to choose that when you're choosing those services. The next thing we want to talk about is availability zones in Azure regions. Availability zones have been around for about 2 years now. They are within a given region, you will have multiple data centers. And some of these data centers are very close to each other, but many of them are separated by up to 10 miles. And these are called availability zones, and that's how they're broken up. And the idea behind availability zones is they are close enough to each other that they can support things like synchronous replication. So this is a very valuable tool in building highly available solutions in Azure. And so if you use availability zones, you can have synchronous replication, and so your uptime will be a lot higher because you'll have almost zero data loss, or almost zero potential for data loss, and B, you can fail over between these different zones relatively quickly. Whereas if you use regions and you're replicating data across the United States, for example, the problem with that is that the latency is too high, and so a failover almost always implies some amount of data loss in a region-to-region failover, whereas zone-to-zone can be synchronous replication if correctly architected. The next availability component is an availability set. And these have been around a lot longer. Availability sets have been around since Azure started for the most part. And what these do is it allows you to deploy virtual machines into a availability set. And when they are deployed in an availability set, that tells Azure that these machines are doing a similar job and are part of the same solution and should be deployed to different host machines, for lack of a better term. In reality, they're not deployed to different hosts necessarily, but different components in the data center that are called fault domains and update domains. So what do I mean by that? A fault domain is designed to handle things like physical failure of the infrastructure that's running the host. And so that's things like power supplies and the backplane of the hardware, those types of things. And so you can have up to 5 fault domains. And that means that if I have a web farm with 5 servers in it and one power supply fails and there's no redundancy, which there is, but if there were a failure of a power supply, it at most would only impact 1 server out of the 5. There are also update domains. These are designed to help minimize downtime from scheduled patching and other scheduled maintenance. And so these, you can have up to 20 update domains in an availability set. And so if I had, let's say I had 100 servers in a web farm and Microsoft decided they needed to apply a patch, it could take down up to 5 of those servers. So, and that's the concept of an availability set. Generally speaking, availability zones are going to have higher availability than an availability set, and would be considered stronger availability than an availability set, but not all regions support an availability, have support for availability zones yet. Because it requires, physical data centers to be relatively close to the other data centers, it takes longer for Microsoft to build out availability zones. So not every data center or every region in Azure has availability zones yet, but more are being added all the time. Within Azure, when you start getting down to actual deployments of individual resources, everything that you deploy in Azure gets deployed into what's called a resource group. And a resource group is a logical grouping of resources that are related generally on a security boundary and lifecycle boundary. So what do we mean by that? So the best practice for creating resource groups is that all resources for a given solution that share a lifecycle will go into the same resource group. So that if I was deploying a virtual machine, that would be the virtual machine itself, that would be the disk resource, the network card resource, any other application services that I might need for the solution would all go into that same resource group. What would not be considered part of that would be something like the underlying network configuration. those virtual networks would usually be installed in their own resource group. Why wouldn't my network be part of my solution? And the answer to that is, if you look at how networks are managed, they are usually managed by network administrators. So network administrators usually are the ones going in, configuring the IP ranges, the subnets, and they're the ones that manage all the connectivity and everything. And you don't want, database administrators going in and tweaking those. So usually you partition those off and put them in their own resource group and lock down that resource group so that only network administrators can access those resources directly. That doesn't mean that other services and virtual machines won't be able to use the network. It just means that managing the Azure service itself would need to be done by a network administrator. As far as other application resources go, they should be related to each other and share the same life cycle. So that means if I'm going to delete one of those resources, I'm probably going to delete all of those resources. So that's usually a pretty obvious thing to point out. Now, there's nothing in Azure that prevents you from putting every resource you create into the same resource group. But every resource is required to go into one and only one resource group. There's no way to put a resource into multiple resource groups. So everything can go into one resource group, but for your own sanity, you should put things that have a shared life cycle into their own resource group. You will hear a lot of talk in your Azure learning about Azure Resource Manager. And this is basically the interface for managing and organizing all of your cloud resources. This is how you deploy resources. And if you, it's sort of the fabric that helps you manage all of these different resources. So no matter how you're doing your deployments and resource management, it's always going through Azure Resource Manager. It doesn't matter if you are a new user using the Azure portal for everything, or if you're a system administrator deploying with PowerShell, or if you're a developer writing, deploying services through the REST API. You're always going through Azure Resource Manager to do that. All right, so a little knowledge check here. So pick the term that best describes the feature that is made up of one or more data centers equipped with independent power, cooling, and networking. It is set up to be an isolation boundary. If one goes down, the other continues to work. They are typically connected to each other through very fast private fiber optic networks. The correct answer to this is availability zones. Each availability zone is made up of one or more data centers equipped with independent power, cooling, and networking. It's set up to be an isolation boundary. If an availability zone goes down, the others continue to work. And the zones are typically interconnected with private fiber optic networks and do support the use of synchronous replication. All right. So on services in Azure, there are hundreds of services in Azure. We're not going to cover every single service in Azure, but there are a variety of different services for different tasks, and there are new services added all the time. The foundation of Azure is going to be in the infrastructure services. And this is going to consist of your compute resources. This could be virtual machines, and it can also be containers. And these would be infrastructure compute resources that you manage. Following that, you have Azure Storage. This consists of blob storage, Azure Files, and then there's also Azure Premium Storage, which is storage that is backed by SSD, and it's just generally faster than standard blob storage. And then finally, you have networking infrastructure. This consists of virtual networks, Azure load balancers, the Azure DNS service, which is a global DNS service that exists in every Azure region. It's worth noting that you don't have to deploy Azure DNS. It just exists when you deploy a virtual network. It's there and running. You have Azure Express Route, which is a way to directly connect your on-premises data center with Azure through a private link. It's considered the fastest and most secure hybrid connectivity option. You have Azure Traffic Manager, which is a DNS router. It is globally available, similar to Azure DNS. It's built on top of Azure DNS, and it allows you to do things such as direct traffic to a particular region for either disaster recovery purposes or for localization purposes. Let's say you have a version of your application that runs in the United States for English speakers, and then you have a version in, say, Japan, and you want anybody that accesses your site from Japan to be routed to the Japanese version. You can do that with Traffic Manager, and it has that capability. You have VPN gateways. VPN gateways are designed to support hybrid connectivity with your on-premises data center through normal VPN connectivity. You have application gateways as well, which is very similar to load balancers, but work at a different layer of the network stack and provide you with some other advanced features like web application firewalls, HTTPS and SSL offloading, and a bunch of other more advanced features as well. These all fall under infrastructure services. Next, on the left here, you have security and management services. This will be things like Azure Active Directory, the Azure portal itself, multi-factor authentication, Azure Automation, Azure Key Vault, the marketplace for Azure. You also have, on the far right, you have hybrid operations. This is all the Azure AD services that can integrate back with your on-premises solution for Active Directory, Azure Backup, Operations Management Suite, the Azure Import-Export tool, Azure Site Recovery, and some other services as well. And then finally, you have the platform services. These are broken up into a variety of compute services for different use cases, a lot of web app and mobile app and API app options, data services such as SQL Database, SQL Data Warehouse, Cosmos DB, analytics and IoT, machine learning, HD Insight, Stream Analytics, other services, integration services for connecting different components of a cloud service together, media and content delivery networks. If you're not familiar with content delivery networks, these allow you to have users, when they access your websites or your storage accounts, the content delivery network can cache the items that they're accessing closer to the user so that the next user that accesses it will get the cached copy instead of having to make a round trip all the way back to Azure again. And that generally just speeds up performance. All right, knowledge check time. Suppose you have an existing application running locally on your own server. You need additional capacity, but prefer to move to Azure instead of buying upgraded on-premises hardware. Which compute option would likely give you the quickest route to getting your application running in Azure? Azure virtual machines would probably be the easiest. This is called a lift and shift when you do this, and it is a very common, the term lift and shift will probably be on the exam. And basically what it means is to take your machines that you're running on premises and run them in Azure. Exactly the same configuration and setup, very minimal change. And the idea behind this type of migration is to make as few changes as possible so you can get the environment running in Azure as quickly as you can with the minimal amount of work, obviously. All right, which service offers a distributed network of servers that can efficiently deliver web content to users that focus on minimizing latency? So this one is the service that I talked about. This is the content delivery network. This is a distributed network of servers to deliver web content to users. It's a way to get content pushed out to the user's local region. The reason this works is that a content delivery network has a lot more endpoints than there are Azure regions. There are typically hundreds of endpoints for content delivery networks, and there are less than 100 Azure regions. So these can provide much reduced latency. So as I mentioned before, there are a lot of different Azure services here. There are products that are meant to accelerate your development. There are analytics and IoT options here, such as Azure Machine Learning, which is designed to help you build and deploy machine learning models. There's Azure Data Factory, which is designed as a data orchestration tool to help you move data and process data in a data pipeline. Then you have real-time streaming agents like Azure Event Hubs, Azure IoT Hub, and Stream Analytics, which are all designed as data ingestion and micro batch processing tools. You also have the integration components that I mentioned here. These would be things like storage queues and Azure Service Bus, BizTalk services, and hybrid connections. These are all made to interconnect different Azure services. And the idea behind these integration components is when you move things into the cloud, one of the core tenets of cloud architecture is to decouple services from each other. So think of a typical 3-tier application. You might have, in a 3-tier application, you will have things that are, you'll have a web front end that is synchronously linked to a middle tier, that is synchronously linked to a data tier on the back end. So if I, as a user, if I create some order on the front end, it puts the order into the middleware, which then commits a transaction to the database, and that's how I know that I have an order. And I don't get a confirmation on the front end until the data tier has the commit hardened to its log. Well, if you do this in the cloud, that means that whenever you meet a scalability limit on one of those 3 tiers, you have to scale the entire architecture up to support greater scale. In the cloud, you want to decouple these services from each other so that each one can be scaled independently. When you do that, you need some way to interconnect those different services, and you can do that through these integration services like Service Bus and storage queues. And what these allow you to do is you can write a message or an event to a storage queue or Service Bus or a BizTalk service, and that event will live there until the consumer is ready to consume that event. So for example, in my 3-tier architecture, if a user submits an order, I could put that order into a storage queue, and then on the back end, some other processing service might run like an Azure function that would pull that message out of the storage queue and then do the commit on the data side for me asynchronously from the actual order itself. And that order can live in the storage queue for quite a while, and it allows you to scale those different services independently of each other. And when they operate on those queues, they can operate at their own pace. On the data side, you have tools like Azure SQL Database, which is SQL Server running in Azure, and it's a platform as a service offering. You have Azure SQL Data Warehouse, which is a scale-out dedicated data warehouse service. Redis Cache, which is designed to sit between your data platform and your application as a in-memory cache to speed up access to your data. You have Cosmos DB. The old name for Cosmos DB is Document DB, and you can see that on the slide. But Cosmos DB is a document storage. It has no schema, or at least it doesn't enforce a schema on your data. And it has the advantage, in addition to being schemaless, It also has the advantage of being able to ingest data at a very rapid pace, and developers can control how consistent that data is across a large scale-out cluster. So this gives you a lot of different advantages to that. On the web side, you have Azure Web Apps, API apps, and API management, mobile apps, logic apps, and notification apps. These are all part of the same underlying service and just different deployments of that service. Web apps is obviously designed for hosting web content like a website. API apps is designed for you to build and deploy APIs so that other applications can call into your API. And API management is a way for managing those API apps. Mobile apps is designed to help you build mobile applications. It works hand in hand with notification hubs. Notification hubs are quite unique. They allow you to send messages to your mobile application across any type of mobile device. So if I have a mobile application that has different versions for iOS, for Android, and Windows, I can push notifications out to those different platforms through notification hubs, and it manages the customization of each message to the different proprietary platform messaging system. And then finally, you have logic apps in this space. This is a pretty cool feature, and it allows you to have a code-free mechanism for building applications so that you can interact with different Azure services and third-party services. And it has a lot of built-in connectors and control flow language and things like that that allow you to build complex logic inside of it without knowing how to do any code. You don't need to know Node.js or .NET or C# or anything to take advantage of logic apps. So your company has multiple web properties that a customer can reach you from. You would like to create a common set of code that each of them can use to create a lead in your customer database. Which service of Azure App Service would you use? Web app, mobile app, API app, or web apps for containers? If you want to create a common set of code, and we didn't go into too much detail on this particular answer, the correct answer would be an API app. This is designed to expose functionality as an application programming interface, or API, and that allows multiple types of clients to use the same underlying code base. They'll use a common protocol like HTTP to make the connection, and then they can issue the call to the API. And you don't really, as an API developer, you wouldn't really care how the application was written. You're just providing an API. You see these a lot out in the world. Lots of different services like weather services and things support APIs that allow developers to take advantage of those different services. Which service below is not considered a feature of Azure Serverless computing? So we did not specifically call out serverless computing, but let me go through each one of these first, and then we will decide which one is not a serverless compute. Azure Machine Learning is a service in Azure that is designed to facilitate the building of machine learning models. Machine learning models, if you're not familiar with machine learning models are the underpinnings of all artificial intelligence applications. So all AI applications under the covers are using machine learning models that some data scientist somewhere had to take in data, analyze, and use algorithms on that data to try and predict outcomes. And to do that, that whole process is called training the model. When they train a machine learning model, they can use Azure Machine Learning to train the model. When they're done training the model, they can operationalize the model through Azure Machine Learning and publish it, similar to an API, through Azure Machine Learning services. Next, you have Azure Functions, which is a service in Azure that can run small snippets of code for you. And the idea behind this is that you only pay for the compute time that you use. This is definitely considered a serverless computing function service. The next is Logic Apps. This is also a service serverless option. And like I mentioned before, it allows you to create applications with no code knowledge. Very similar. You can actually build things in Logic Apps that you might also build in an Azure function. They can both serve very similar purposes in some cases. But Logic Apps is designed to be code-free. Azure Event Grid is an event solution that allows you to do things like trigger serverless computing tasks by monitoring. So for example, if I have an Azure storage account and I want to trigger an Azure function every time a customer drops a new file in the storage account, I can set up Azure Event Grid to monitor that storage account and then trigger the function for me on the behalf of the user. So it is also part of serverless computing. So Azure Machine Learning, on the other hand, is really not considered part of serverless computing. There are definitely servers that you can deploy with Azure Machine Learning through notebook virtual machines and other services. You also operationalize your machine learning models with Azure Machine Learning. So that is where why I would say Azure Machine Learning is the one that is not serverless computing. All right, so let's talk a little bit about the Azure management tools. The first is going to be the Azure portal. And this is the primary interface for accessing Azure and where almost every person new to Azure starts out. And in fact, you'll probably remain using the Azure portal for ever, as long as you're using Azure. The reason for that is every time a new service comes out, until you get familiar with how the code works for that service, you'll probably do things like deployments by using the Azure portal. It gives you a really good way to visualize what you're deploying in Azure. The other thing is it's a visual interface and it's pretty self-explanatory. If you want to create a resource, you click on create a resource and then you just search for the name of the resource and it gives you sort of a wizard-based deployment option. Very easy to use, very easy to navigate. The other option that you'll have is Azure PowerShell. And Azure PowerShell is based on normal PowerShell. It's just a set of commandlets that is specific to the services in Azure. Every service in Azure has PowerShell commandlets. So anything you can do in the portal, you can almost for sure do with Azure PowerShell as well. Next, you have the Azure command line interface. And this is a cross-platform command line scripting language. It runs on Windows, Linux, Mac OS, whatever. It can also run from the Azure portal, actually, using a service called the Azure Cloud Shell. And the Azure Cloud Shell is browser-based, but it's a command line interface that you access from the Azure portal. And then you can run PowerShell or CLI commands from the Cloud Shell. It also has support for a lot of other tools that you can use that are easily integrating with Azure, such as Azure Storage Explorer, AZ Copy, VS Code. Even some of the SQL command line utilities will be installed in the Azure Cloud Shell. The real power of the Cloud Shell is that you don't have to maintain anything on your local machine to take advantage of the Cloud Shell. It's automatically kept up to date for you. If you try to install Azure PowerShell in the Azure command line interface locally, that's fine and it will work, but you will need to keep up with the releases, new versions of those, and have to update your version. And that can be quite a hassle. So having to maintain all that stuff can be a hassle. So you have the option of using the Cloud Shell to do those same tasks. All right, security, privacy, compliance, and trust. So network security in Azure. So you have a couple of different types of network security that you'll need to consider when locking down your networks in Azure. First are your outside or outer ring of network security. This is the Azure Firewall, Azure Distributed Denial of Service Protection, which is actually on by default. You have network security groups, which allow you to help lock down your virtual networks. And then you have application gateways, which give you access to the web application firewall. The inside perimeter will focus on server-to-server communication. This also includes Azure Firewall. It also includes network security groups. It also includes application gateways. And then additionally, it has what's known as a service endpoint, and then you have service level firewalls as well. A service endpoint is used for you to connect to a Azure platform as a service offering from within an Azure virtual network. So you might have a virtual machine running in a virtual network, or your on-premises network might be connected to an Azure virtual network, and you want to connect to an Azure platform as a service offering without traversing the public internet. Then you can use a service endpoint, and that will give you direct access to that Azure platform as a service offering. Service level firewalls are very similar to Azure firewalls. Azure firewalls simply are on your virtual network and allow you to lock down the virtual network similar to a normal firewall. But a service level firewall is a firewall that's deployed with the service, and they always exist on the services that have them. So things like Azure SQL Database, Azure Storage, all have service level firewalls. You can lock down those services from those firewalls so that people can't access those services except from either specified networks, specified IP ranges, those types of things. All the firewalls in Azure typically work in a very similar fashion through what's known as a whitelist. And you establish the whitelist by defining what services or IP addresses can access that particular service. All right, so which of the following is not a method for protecting internet-facing services from network attacks? Azure Distributed Denial of Service, Application Gateway, Web Application Firewall, Azure Disk Encryption, or Azure Firewall. The answer is disk encryption. Disk encryption is not designed to help protect any network services at all. It's designed to protect the data that is stored in a virtual machine disk. And in Azure, every virtual machine will have a disk resource of some type, either sitting on an Azure storage account if it's an older virtual machine, or newer virtual machines will have what's called a managed disk. And in either case, you can enable Azure Disk Encryption, and Azure Disk Encryption will encrypt that disk so that even if somebody does get hold of that file that represents your disk, they will not be able to read the data in that file. Distributed denial of service can be used to protect internet-facing services from denial of service attacks. Application gateway, web application firewalls are used to protect internet-facing services from things like cross-site scripting and SQL injection. And then Azure Firewall is a cloud-native firewall designed to provide customized network protection traffic, and it requires inspection from the virtual network, so it also protects you from those outside network attacks. Next, we want to talk about identity services. Identity service in Azure is backed predominantly by Azure Active Directory. And Azure Active Directory, it's a very common misconception that Azure Active Directory is just the regular Active Directory we all know and love running in Azure. And that is not the case. Azure Active Directory is completely different from on-premises Active Directory. It has compatibility with some of the features of on-premises Active Directory, and you can integrate the two, but they are completely different animals. Going into the level of depth needed to understand those differences is a little out of scope, but we'll cover some of it in this class. Azure Active Directory is a comprehensive identity and access management cloud solution. It provides a robust set of capabilities to manage users, groups, and to help secure access to applications, including Microsoft Online services like Office 365 and a variety of non-Microsoft SaaS applications as well. In other words, Azure Active Directory supports the typical type of Microsoft authentication you would expect, like you would have in Azure Active Directory or in Active Directory on premises. And it also supports authentication through third-party services as well, things like Google and Facebook and those types of things. So if you have applications that need that level of authentication, you can offer that as well. So let's kind of go through some of the tools we have available to us to govern our resources in Azure. The first one that you should understand is subscriptions. And subscriptions in Azure are usually how most people first start dealing with billing in Azure, is at the subscription level. And the reason for that is because if you go to Microsoft and you say, I want to get a trial subscription, they give you a credit of a couple $100 over 3 months, and they give you that credit based on a subscription boundary. Subscriptions are billing and security boundaries. How they are managed depends on the type of enrollment that you have received that subscription through. There are several different types of enrollments. There are enterprise enrollments. These are typically received through an enterprise agreement or EA agreement from Microsoft. There are pay-as-you-go subscriptions. Pay-as-you-go means you go to portal.azure.com. You don't have a subscription, so you click a link that takes you to a sign-up page. You give them your contact information and your credit card information, and then every service you deploy is paid through that credit card. That's a pay-as-you-go subscription. There are dev test subscriptions. These are this is sort of a synonymous with lots of different types of subscriptions that you might run across. So examples of this are trial subscriptions that I mentioned before. If you have an MSDN or Visual Studio account or subscription, those will always come with some amount of Azure tied to it. Those are considered dev test subscriptions. And the benefit of those subscriptions is that they are spend capped typically, so that you won't overspend if you deploy an expensive resource on Friday afternoon and forget about it and then go home. It won't cost you any money because it's got a spending cap on it. So, and it's just sort of tied to that subscription. And then there are a variety of other subscription types that you might run across that are a little more specialized, like a CSP, cloud service provider subscription, and some other things similar to that. But predominantly, you're going to be looking at the dev test subscriptions, pay-as-you-go, and EA subscriptions. So all of the services that you're going to see in Azure are controlled via role-based access control. And role-based access control is used to apply role assignments to identities that are sourced from Azure AD. So in other words, I go in, I create a user in Azure AD that has a user account and password. I grant them role-based access control through the Azure portal to my subscription, and I can lock down individual resources or give them access to individual resources inside of my subscription. That's called role-based access control. Every service in Azure supports role-based access control to some degree or another. If I create a user in Azure AD and I do not grant them any role-based access control in my subscription, even though I own Azure AD and I might give them global administrator in Azure AD, if I don't grant them role-based access control permissions to an underlying resource, they will not see anything when they log into my Azure subscription. There are 3 core roles in role-based access control, and all other roles in Azure are developed and evolved from those 3 core roles, and they are owner, contributor, and reader. Owner means I can do anything. I can create, delete, modify resources. I can also change security permissions as well. Contributor means I can do everything except change security. And reader means I can only read. I can't do any modifications to the resources. There are some services in Azure that will have other permissions inside of them. So things like SQL databases, virtual machines can also have their own security within them. And those are different from role-based access control. Role-based access control can be inherited from a parent resource. So if I grant somebody owner privileges on my subscription, that means they have owner privileges on all the resources underneath that subscription as well. You also have policies. Azure policies are designed to help you prevent users in your organization from breaking any conventions that are needed to manage your resources. You create policy definitions that describe the actions and the resources that you want to control, and you assign those policy definitions through a policy assignment at whatever scope. So if I want that policy to impact an entire subscription, I can assign that policy at the subscription level. If I want to do it at a resource group level scope, I can do that as well, even down to the individual resource. These can also be set up above the subscription level as well. So you can have management groups above the subscription level. So if you are in an enterprise organization, an individual might be given access to an entire management group that consists of multiple subscriptions, and you can do that as well. Use that scope as well for policies also. So also we have the concept of resource locks. And what resource locks do is resource locks prevent users from accidentally deleting resources. So usually these are used for things like production resources. I deploy a production resource. I want to prevent somebody from accidentally deleting it. So I set a lock on the resource group for that service that I deployed. And that prevents somebody from accidentally coming in and deleting it. It doesn't prevent an administrator or an owner from maliciously attacking something. It's just meant to protect you from yourself, basically. And then management groups I discussed when we were talking about policies, but this is an overall group of resources and subscriptions that are managed in a similar way. So a department may have multiple subscriptions that they work with, and they may apply the same policies and role-based access controls to those by default. And rather than logging into each subscription individually and doing those things, I can put them all under a management group, and I can deploy those through the management group as well. You also have the Azure Advisor, and this is a sort of a personalized guide to Azure best practices. It will provide recommendations to help you optimize your resources for high availability, security, performance, and cost. You can implement those recommendations from within the tool, or you can just use it as a checklist if you want to do something like that. If you've ever dealt with an audit, the Azure Advisor is really incredible for audit use, because I can get a list of, things that are not following best practices right out of the Azure Advisor, and I can decide which of those things are related to my my audit, and I can use that as my starting point for that. The Azure Advisor is a free to use service. It's on by default. There's nothing you need to do to change it. It's always there. Some recommendations that it gives you might have a cost implication, but overall, you're not going to be billed just for reviewing the recommendations from the Azure Advisor. But certainly, if it tells you, hey, for high availability, you should deploy this service in a multi-region deployment model, and then you go and do that, that's obviously going to cost you more money because you're deploying the service into 2 different regions. So, but the service itself is free. So, knowledge check time. True or false? Azure policy is used to control per user permissions in Azure and control the types of resources that users can deploy. The answer to this is false. Policy focuses on resource actions. So, example, through policies, you can control the type of resources that can be provisioned. So, if I had a team of database administrators, for instance, I could prevent them from deploying virtual networks, for instance, because I don't think my database administrators should be deploying their own virtual networks, at least not in my subscriptions. So I could prevent them from doing that by applying a policy. Role-based access control focuses on the actions a user can perform. For example, a particular user is added to the contributor role for a resource group, so that means that their user can make changes to that resource group. So it's quite a bit different there. So monitoring requirements in Azure. So when you think about requirements, one of the things you need to have is visibility into the services and the Azure platform. This is all about understanding how an application or a set of services is performing across the board. You'll need to understand what metrics you'll need to monitor and how you can visualize those in dashboards. You'll also want to be able to take deeper dives into your applications, particularly with service or dependency maps and other advanced tracing mechanisms. You may want to use those insights to drive automation and recommendations within your environment. And finally, you'll want to always be optimizing your environment. If you recall the chart that I showed you at the beginning that showed the difference between the Capex model and the operational expenditure model. And in the Capex model, we had that stair-step, spend chart there, and how it did not closely track with the load. The load was kind of all over the place, and I was using that stair-step where I was having to buy big chunks of resources at a time. Ideally, you're monitoring your environment, and the reason you need to closely monitor it is so that you can make changes to the environment to more closely match your load and security requirements. And that's what we mean by optimize. There are other ways of optimizing as well. There are optimizations for things such as security, things such as application modernization optimizations. And the reason those are important is because they usually represent improvements in cost structures as well. So those are definitely falling into this operationalizing your monitoring. From a security standpoint, you have the Azure Security Center. This provides you with security recommendations. It allows you to monitor the security settings and identify vulnerabilities. This is another one of those components that you can use that will help you in your audits and things like that. It can also help you with blocking things like malware, investigating and analyzing threats, and reducing attack surface of your services in Azure. Azure Key Vault is a critical service in Azure. It is a centralized service for storing secrets of any type: connection strings, security tokens, certificates, passwords. It gives you secure access, permission control over these resources, and the ability to log the access to those resources as well. You grant access to a Key Vault. So, for example, if I have an application that encrypts data inside of the application and then writes that data in its encrypted form to some backend database, I'm going to need to grant access to the application to be able to do that, grant access to the key to be able to encrypt that data. And I can store that key in Key Vault and then grant access to the application to the Key Vault instead of actually giving it the actual key or token to do the encryption. And that's a way of disconnecting those two pieces. It also supports the logging for administrators. So as an administrator, I can see who has had access to the Key Vault. Whereas if I just gave the key to the application, I wouldn't really have a standardized way of logging that access to the key itself. That would be, hidden from me as a security administrator. So true or false, with infrastructure as a service, you're responsible for the maintenance and patching of physical operating system hosts in Azure. I didn't specifically call this out in the optimization section. The difference between the host and the guest operating system is what's key to answering this question correctly. The host is going to be something like Windows Hyper-V Server or VMware vSphere. That is the operating system that all my virtual machines are running on top of, not the guest operating system that I have access to. And so the answer to this is false. Microsoft maintains the physical infrastructure for Azure, including the data centers, physical networks, and the physical hosts that your virtual machines and other Azure services are running on. So if your solution requires virtual machines running in Azure, you will not have the ability or any insight into the underlying physical host or its operating system. That is managed by the vendor. That is a common practice across all cloud providers, not just Azure. So from a compliance standpoint, Microsoft is an industry leader in security and privacy requirements in the cloud. It meets a broad variety of industry-specific compliance standards, such as GDPR or General Data Protection Regulation, HIPAA, FedRAMP, SOC, and as well as a variety of country-specific standards in Australia, UK, Singapore, etc. It goes through third-party audits, such as those done by the British Standards Institute, to verify Azure's adherence to those security requirements for those standards. There are some key terms that you'll need to understand. The NIST, or National Institute of Standards and Technology, is a physical sciences laboratory and a non-regulatory agency in the United States Department of Commerce. They define many of the standards that are implemented in the cloud, including providing authoritative definitions of cloud computing, for instance. GDPR is a regulation in EU law on data protection and privacy for all individuals in the EU and the European Economic Area. And controllers of any personal data, including Microsoft, as the controller of Azure platforms in the EU, must put in place appropriate technical and organizational measures to implement these data protection principles. And then ISO or IEC 27001 is an informational security standard. The last version was published in 2013. There have been a few minor updates since then, but it's published by the International Organization for Standardization and the IEC, or International Electrotechnical Commission. And it specifies a management system that is intended to bring information security under management control and gives specific requirements for that, for doing that. Those are just some of the key compliance things that Azure has for it. Azure also has built-in compliance management. It has a variety of assessments for different standards so that you can validate your solutions against these different standards. One way I like to put this for people that are new to Azure when they look at these services, because this is a very common question for people who have no cloud experience. When Microsoft says we have this Azure SQL database is HIPAA compliant or GDPR compliant, that means that Microsoft's portion of that implementation is compliant. Doesn't mean that your application, if it uses that service, will automatically be compliant. You still are able to build insecure applications or non-compliant applications in the cloud. So keep in mind that if you are building things in the cloud and you need to meet some regulatory or compliance certification, you will still have to do that. What will not happen though is you will not be, if your auditors come in, they will not be auditing Azure data centers and things like that. That is handled by Microsoft's auditors, and those types of, that's what the compliance you're looking at is for Microsoft's components. That's what all those compliance certifications are there for. So determine if Azure is compliant for a business need. If you're using a service already, you can use Compliance Manager. You'll have all the tools that we talked about. You also have the Azure Trust Center. The Trust Center is where you find all the documentation around this. If you are having trouble falling asleep one night, the Azure Trust Center is a really good way to go read compliance documentation, and it will cure even the worst insomnia you can imagine, I guarantee it. There's the Azure Service Trust Portal, which is where you can go find a lot of this information and other information around compliance and trust. The Service Trust Portal is a superset of the Trust Center that has additional information other than what you would find in the Trust Center. And then the service-specific documentation, which is the individual documentations for each service and how they comply. If you're not using Azure already, you're going to go to the Trust Center because you don't need an Azure service to do that, and the service-specific documentation. All that is just raw documentation, and you can read all of that without an Azure account. The Service Trust Portal is actually part of Azure, and so you'll need to get access to it. You'll need to go through the Azure portal, so you need a subscription for that. So true or false? You can access the Service Trust Portal and Compliance Manager even if you do not have an Azure account. This is false. The Service Trust Portal and the Compliance Manager are part of Azure, and you must have a valid organizational account that is associated with Azure or Office 365. One of the big things we talk to customers about when they're talking about migration and they've never put anything in Azure is whether or not they have Office 365, because Office 365 is a more ubiquitous service. It's been around a little bit longer. And most organizations that are using Office 365 already have Azure AD set up and configured. So they are able to more easily use Azure. and that will give them access to the Service Trust Portal and the Compliance Manager. But the documentation will be in the Trust Center and in the service-specific documentation. All right, so finally, we're going to talk about Azure pricing and support. So to understand Azure pricing, including cost and cost management, you need to understand the subscription model. A subscription, like we mentioned earlier, is a container for Azure resources, and those resources will be billed on the same bill in a given subscription. So above the subscription level, you have accounts, and accounts can contain multiple subscriptions. So, and if you have a personal account, a personal Azure account with only one subscription, which is what you'll have, that is what you'll have when you have an Azure trial subscription or an MSDN account, then a lot of times the subscription owner and the account owner are the same person. In something like an enterprise environment, those two things are going to be different almost in every case, because the account administrator or billing owner might be an accountant, whereas the subscription owners are usually technical IT staff. So those are different levels. Just know that they are two different levels for the purposes of billing. The account is actually a higher level than the subscription level, so that's how those kind of roll. So true or false, an Azure subscription may only have one account owner. The answer to this is true. Each Azure subscription can have one account owner. However, each account owner may have multiple subscriptions. We didn't talk about that explicitly, but just know that there's only one account owner, and then you can have multiple subscriptions underneath a given account. So planning and managing Azure services. You have a variety of subscription types. You have enterprise, which are negotiated spend commitments purchased directly from Microsoft. Most large, Fortune 500 companies are probably going to have an enterprise agreement from Microsoft, and they will negotiate whatever the spend is they think they'll use on Azure in that account. The pricing is usually not very different from regular pay-as-you-go pricing. A lot of people think that these big companies are able to negotiate much better rates. In general, the rates are so low on cloud computing that there's not a lot of wiggle room to for that. So you don't see Bank of America getting much better rates than some mom and pop store that just has a website. They usually get paying roughly the same rate. You also have WebDirect. This is purchased directly through the Azure website or directly from Microsoft, usually as an individual. And then you have Cloud Solution Provider or CSP subscriptions. And those are billed through a partner. So a lot of times if you go through a consulting company to get Azure services, they will provide the Azure subscription for your solution on your behalf. You will pay the same rate through a CSP as you do through an EA or WebDirect. The rate is basically the same for all the different subscription types. Give or take a few pennies here or there. But the CSP, when a CSP sells you a subscription, they get a cut of the price. So from Microsoft, but Microsoft pays that, not you. So the billing is usually just straight pass through for CSP. They usually don't bill you extra for that. There are various usage meters that are created when you deploy resources in Azure. Some of the more common ones, compute hours, IP address hours for public IPs, data transfer in and out. Usually there's no cost to transfer data into Azure, but transferring data out of Azure does have a cost. That includes when you go from one Azure public endpoint to another, it usually transfers data across the internet when you do that. So that might incur a data transfer cost as well. To determine whether or not it does, you would have to read the documentation for the service to find out how that would work for that particular service. Managed disk, storage, all kinds of things will come up in these usage meters. And these will all roll up on your bill. And then your bill can also be broken out into various other things, including custom elements that you can manage through resource tagging, which is just a key value pair that you assign to a given resource so that you can identify it. Those tags that you create for a given resource actually roll up in your bill, and then you can filter on those as well. Different cost management tools that you might have. The Azure EA portal, Enterprise Agreement Portal, allows customers with an EA to manage their subscriptions. You can manage your costs through the Azure portal. Resource tags, like I just talked about. Azure Advisor recommendations, we talked about it a little while ago, can help you with cost management. Setting spending limits is another good way to manage your cost. Using consumption billing and reporting APIs in Azure. If you need more customized solutions, that is what you will use. If you work for a CSP provider, you probably are creating, or somebody in your organization is creating, tools that use those APIs to help manage costs for your customers in Azure. Invoices and usage provided by cloud service vendors. And then there is an Azure cost management tool. It used to be called Cloudin. That was the name of the company that Microsoft bought or acquired in 2017. And that tool can help you manage billing as well. Support plans in Azure. There are a variety of different ways you can get support for Azure. What we're talking about for right now is simply the online options here on the left. All support for billing is generally free. So if you have a disagreement about a bill in Azure, that is a free support ticket that you can open directly from the Azure portal, and they will not send you a bill for that, or they will not bill you for that. The Azure product and service documentation is generally free. I think the only service I can recall that doesn't have freely available documentation is Dynamics. You actually have to have a support plan to get access to that documentation. That's actually very common in that space, that business software space like that, which is Dynamics and SAP and those types of services, all lock down their documentation so that people that don't have access to it can't reverse engineer the software. Online self-help is always available. The online documentation for Azure is very good for in general. From an industry standards point of view, it's very good. They also allow you to contribute to the online documentation. So if you don't agree with it or you find things that are wrong, you can actually basically just sign a document, and then they will allow you to make updates to that and check in things into their GitHub repos for the documentation, and you can make modifications to it. There are community support forums. MSDN has community support forums, serverfault.com, Stack Exchange. There's a variety of community support forums. The Azure development teams actively participate in the more popular ones, such as MSDN and Stack Exchange and those kind of things. Azure Advisor recommendations are always free. Azure Service Health Dashboard and Health APIs are free to use. The Health Dashboard is available directly from the Azure portal. By default, you'll see it right on the front of the dashboard in the Azure portal when you first log in. But anybody has access to that. You can just do a search for Azure Health Dashboard and you'll find it. There are also paid support plans. that give you access to Azure support engineers. In certain cases, you might be able to get access for free in certain cases, but don't count on it. But it is possible. I have had support tickets that were originally opened as billing cases that moved into support and were answered by support, and they did not bill me for them. So there are cases where that happens. Also, when you need to do things like increase a quota, that falls under billing, but it has to be done by an Azure support engineer. Now, if you can't figure out how to get your application to work, that's going to be a support ticket, and you're going to have to pay for that. But interoperability and configuration guidance and troubleshooting, that's handled by Azure support engineers and some of the Azure development teams. Architectural support, handled by those same teams. Operational support, including service reviews, reporting, web-based training seminars. Those all roll up depending on what type of support plan that you might have. There are 4 different tiers of support plans. There are, let's start with the cheapest first, that is developer. Developer support is appropriate for trial, non-production environments. It gives you access to business hours support via email. It's generally for severity C or minimal business impact cases only. And it is less than 8 hours response time for initial response. Now, it's less than 8 hours, and for all these, I'm giving you an hour number, but it's typical that the support engineers respond actually faster than what these SLAs are for these. But developer support is an SLA of 8 hours or less. Standard support, this is appropriate for production environments. It includes access to support engineers via email and phone 7 days a week, 24 hours a day. And it gives you the ability to open critical business impact issues, which are normally called SEV cases inside of Microsoft. The response time for these standard cases is less than 1 hour. Professional direct is appropriate for organizations with business critical applications running in Azure. It includes everything in standard, plus escalation management for high priority issues, proactive guidance from delivery managers, onboarding of services, service reviews, Azure Advisor consultations, architectural guidance based on best practices, and Azure engineering seminars and webinars and those type of things. So basically training for areas that you might be interested in. If you would like sort of the professional direct touch, and you are working with something like a preview service or a beta service that's brand new, if you enroll in the beta for those, a lot of times you'll get access to the engineering teams directly through like a weekly meeting or something to that effect as well. So you can get that same level of engineering touch from the Azure development teams. Beyond that, there is also Premier support. And this is for organizations with a substantial dependence on Microsoft products, specifically Azure. It includes everything in ProDirect, support assistance for all Microsoft products and services. Usually the response time is less than 15 minutes. And it gives you access to Azure Rapid Response if you pay an additional fee on top of the Premier support. It gives you service reviews, reporting delivered by a technical account manager, customer-specific architectural support and design reviews. So they will actually look at your solution, look at your requirements, give you tuning recommendations, configuration recommendations, and architectural guidance based on what you're trying to do specifically, not just based on best practice. They will also give you implementation assistance as well. So if you have a large rollout that is absolutely critical and cannot fail, you can have them, they can actually staff that for you and have people on standby waiting to help you if you need that. So, knowledge check time. Your organization relies on Azure services for hosting a critical application. You need 24/7 support for your Azure services. Which of the following support plans is the most economical option that still provides you with 24/7 support? The answer to that would be standard. Most economical offering that still gives you 24/7 support. Developer tier is the cheapest, but it doesn't give you 24/7. And then the other offerings are 24/7, but have more cost associated with them for those additional features. We're getting close to the end. I know I'm running a little bit behind, but we're almost there. Service level agreements in Azure. Every Azure service has a service level agreement unless that service is in preview. Service level agreements define the uptime guarantees and what the penalty that Microsoft will apply to itself in the event of downtime. Service level agreements can define not only uptime, but performance guarantees as well. So even just because the service is up, if the service isn't performing to its expected performance levels, then Microsoft will either discount your usage or provide some free amount on the cost of that. Some services do require special configuration to be eligible for an SLA. For example, the SLA for a virtual machine is 99.9%, and there is an SLA for that. There is a configuration requirement for that SLA. To get that SLA, you must use premium disk. And all you need to do is deploy a virtual machine with a premium disk, and you will get an SLA of 99.9%. If you deploy a virtual machine with standard disk, you get no SLA. That doesn't mean you won't get 99.9% uptime. It just means that Microsoft is not holding itself to any service level agreement for that virtual machine. Any changes to the SLAs, you can get notification of at the SLA summary page, and those will be issued 90 days prior to the change. When you are architecting solutions in Azure, you will almost for sure be using multiple Azure services. To determine the SLA for the entire service or the entire solution, the way to do that is to multiply the SLAs with each other. People try to do averages and all this different stuff. That's not correct. It is multiply each one with each other. So, for example, here we have the SLA for Azure Web App being 99.95%. The SLA for SQL Database is 99.99%, and the SLA for Azure Active Directory is 99.9%. If your solution relies on those three services, then the SLA is all the SLA for each one multiplied by each other, which is 99.84%. So that I can almost guarantee you will have something about a composite SLA on the AZ-900 exam. So true or false, Azure SLAs are defined by the service tier of the product as below. Basic 99.9, standard 99.95, and premium 99.99%. And the answer to this is false. Each Azure service has its own SLA, and configuration and service tiers may have an impact on the SLA, but is not the only thing to consider. Service life cycles. Within Azure, you will run across various services in various degrees of release state. So you have planning and development services, preview services, general availability, and then retirement or deprecation. So for development, products that are generally not available to you, but may be available to you in certain cases, will be in planning and development. These are also, I would consider these alpha stage. You won't see these in the Azure portal typically. And to get access to something in this stage, you either need an invitation from Microsoft or you need to put in a request in almost every case. And in most cases, you will not get access to them. These are not ready for public consumption yet. A lot of times they don't work or have not fully implemented the entire feature set or even a significant portion of the feature set at this stage of the life cycle. Preview features. These are products that are available for evaluation. They are not intended for production use. They also usually have either no SLA or a very reduced SLA. A lot of people call this beta, software being in beta. It is also from if you're used to on-premises environments and working with beta features there, they were called the early adopter services most recently, and that would be preview features. These can be private preview. Private preview might mean the service is in preview, or it might mean it's still in active development. But if it's in public preview, you'll have access to it. A lot of times, services that are in preview, you have to request access to them. It doesn't mean, that you can't use it. It just means that you're going to have to you might have to fill out a form or answer a couple of questions about how you're going to use the product. I highly recommend you do not use preview features in production. They state that clearly for all preview features, but Microsoft is very well known for having services in Azure that go through 2 years of development, get almost to the end, they feel like fully baked products and ready for general availability, and then at the last minute, they completely yank it, throw it out, and redo the entire feature. This happened with Azure Machine Learning Services a couple of years ago. So please don't use these preview features in production unless, and this is a big caveat, unless you are actively enrolled in the preview for that particular service. If you are actively enrolled, you will know because you would have had to sign some forms and legal paperwork to not reveal information about the product, and you probably would have jumped through some other hoops to get into that program. You would probably be meeting with somebody from that product team on a regular basis to discuss your usage of the product and what your feedback is about the product. So you will know if you are in the program. If you just go to the Azure portal and sign up to say, yes, I would like to try out the preview feature, that is not what we're talking about. We're talking about active participation in the early adopter program for that preview feature. General availability is all the services that are in Azure today that you see out there. All those services that are designed for production use and fully supported by Microsoft at their full SLA. Then you have retirement. Older products that have been deprecated are considered in retirement. This doesn't mean they're offline, but it usually means they're not getting updates. If something is retired, you should be actively planning to get off of it soon. It does not mean it's not broken, don't fix it. It means that Microsoft may make a change in the future that could break it and they won't fix it. So anything that you're working on that's in retirement or has been deprecated, you should be actively working towards moving your service away from off of that service, moving your application off that service. All right, knowledge check. At which stage of the Azure service lifecycle should you consider an Azure service in production? Development, public preview, private preview, or general availability? And the answer is general availability. So we kind of beat that to death, I hope. Definitely do not use services that have not been released to general availability in production. Another common term you'll hear is people will use the term GA, and they will use it as a verb frequently. This service just GA'd last week. That means that it was released to general availability. So just make note that a lot of people will use that term as kind of as a verb. So that ends our exam cram for today. I want to thank you for attending, and if you hopefully you guys have all taken the AZ-900 course already. If you have not, we have an AZ-900 course available that you can take on skillmeup.com. If you have any questions about the exam or preparing for the AZ-900 exam, please feel free to contact me. My email address is paul@optagility.com, and I will be happy to answer any questions you might have. Thank you.